Hello guys, today we are going to do the fourth order non-homogeneous differential equations by using our D⁴ method. And first, we are going to find the homogeneous solutions to these differential equations. First, we are going to find, you see the fourth power, so this is m power of 4 minus the 0th derivative, so this 1 is equal to 0. And then we are going to write this m power of 4 as our m square and then square. And then minus 1 square like that. And then by the identity a square minus b square, you can write this as a which is m square plus 1 times m square minus 1, which is equal to 0. And then you are going to deal with m square is equal to -1. So take a square root plus or minus on both sides, so you can get our m. First solution to this is plus or minus I, and then put the -1 to right hand side, and then take a square root on both sides. You can get m is equal to plus or minus I, or m is equal to plus or minus 1. Therefore, our homogeneous solutions to these equations, or you can use the variable c, complementary functions, which is the same as homogeneous functions. They are really similar. The meaning is really similar. First, you're going to get I, 0 plus or minus I, so you can get e to the power of 0, just 1. And then times c1, right? Remember the formula? Times c1 cosine of how many I? This 1I, so this 1 times x, which is x, and then plus c2 sine x, and then the right hand side plus or minus 1, so you can get two solutions, which is c3 e power of x plus c4 times e to the power of -x. And then we are going to use the variation of parameter. Find the particular solutions to these differential equations. But we are not going to differentiate for 4 times. This is just too crazy, So D⁴ method is way better here. First, you are going to get 4th degree. So we are going to write this as d power of 4 minus the 0th degree. So this is d power of 0. So this 1 times y, which is equal to e power of 3x times sine 2x. And then we are going to divide it by d power of 4 minus 1 on one side, so we can get y is equal to 1 over d power of 4 minus 1 times e to the power of 3x times sine 2x. By the identity, when you do something like that, 1 over f of d, and then e to the power of kx like that, and then time some function like u of x. This can be any functions except for e to the x or something. You can just put the e to the power of kx inside it, and then just put our f of d, just replace this with our d plus k, and then times u of x. So let's do this. First, we are going to take out the e to the power of 3x in front, and then we are going to replace this d with our d plus v. So this d plus v power of 4 minus 1, and then times sine x like that. And then we are going to expand this by using our Young's triangle. I know. When you are going to do the polynomial power of 4, first we are going to get 14641 like that. First we are going to get d power of 4, and then plus, and then decrease the power by 1. And then in front you have a 4, right? So this is, let me write clearly. So this is positive 4, and then decrease by the power by 1, and then times 3 power of 1, and then plus 6 times d square, and then minus, and then this we are going to increase the power, and then plus another 4 times d, and then times 3 power of cubed, and then last term, which is 3 power of 4 and then minus 1, and then times sine 2x like that. Therefore, you are going to get a really confusing term. Let me use our calculator. So d power of 4, keep it, and then 4 times 3, which is 12. And then 9 times 6, 3 squared, which is 9 times 6, which is 54. So this you're going to get 54 here times d squared, and then 4 times 3 cubed, which is positive 108, and then times d, and then 3 power 4 minus 1, which can give you plus 80, and then side to x. Whenever you do something like that, d squared, you know, you can replace this by negative this thing. Whenever you do something, 1 over f of d, and then times sine or cosine kx or cosine kx. You can just replace this, right? Whenever you see something like d squared here, you can just replace this by our negative k squared. So let's just do this. So first thing, you are going to get our d power 4, which is d squared and then square, and then d squared, which is negative 2 squared. So this is gonna be negative 4 and then square, and then plus 12. First we are going to write this as d squared times d, and then d squared, which is negative 4, you know, and then times another d, and then plus 54, and then d squared, which is negative 4 again, and then plus 108d plus 80, and then times sine 2x. And then we are going to simplify it, and then first we are going to calculate d first. So 12 times negative 4, which is negative 48 plus 108, and then you can get 6d, and then the constant term, which is 16, negative 4 square, parentheses square, which is 16, and then minus 54 times 4, and then plus 80. It will give you negative 120, and then times, let me just draw the fractionalized kind of shorter, like that, and then times sine 2x, and then we can factorize the 1 over 60, so you can get 1 over 60 times e to the power of 3x times 1 over d minus 2 sine 2x. And then here, how can we deal with this 1 over d minus 2? We are going to multiply by the conjugate of it, which is d plus 2. Don't forget about the parentheses. We do this because we can just get the bottom, which is d squared minus 2 squared, which is 4. You can get a d squared. You can get rid of this d squared on the denominator, like that. And then d squared, which is our, you know, this is equal to negative 4, and then multiply by each other. Yeah, negative 8 minus 4, which is negative 8. So you are going to multiply by negative, or multiply by 1 over negative 8 in front, and times e to the power of 3x, and then time. First, we are going to distribute the sine 2x, so you can get d our sine 2x plus our 2 sine 2x, like that. And then you can get in front, which is negative 480 times e to the power of 3x, and then do a derivative of sine 2x, which is 2 cosine 2x. Do a derivative of, I don't need to do this because we don't have a d, and then just distribute. Remember, we have a negative sign, be careful, and then distribute 2 over, which is negative 1 over 240 e to the power of 3x times cosine 2x, and then minus 1 over 240 e to the power of 3x times sine 2x. Since we know that this is our y of p, right? Therefore, we can just combine this. So the solutions, that's the solution, which is y is equal to, first you are going to write down the homogeneous part, which is c1 cosine x plus c2 sine x plus our c3 e to the x plus c4 e to the power of negative x, and then this is our homogeneous part. We can write this as y of c, complementary part, and then plus our, and this thing, which is our parameter part, which is, you can just replace this by negative 1 over 240 3x times cosine 2x minus 1 over 240 e to the power of 3x sine 2x. Thus, this is our solutions, and thanks for watching. This is really, really cool. This is our answers, and thanks for watching. This method is way easier to do this thing 4 times, right? Like k1 cosine x, whenever you see 3e to the power of something, I kind of forgot, but whenever you don't have sine 2x, you are going to do our k1 sine 2x, k1 cosine 2x plus k2 sine 2x for 4 times. This just way more harder. So the operator method is way better when you are going to deal with the higher order differential equation like this. And these are our videos, and bye. Stay tuned for more quality videos by me. Bye.